All right, hello everyone, and welcome to part two of the October-November 2020 O-Level PRM for the variant 2.2. Last video we left off where we had discussed the three tasks, what the PRM actually requires of us. We understood the concept of this year's PRM. We understood what we have to do and a brief overview of how we are supposed to do it. And then we also looked at the emulator, which is the finished code, which is how the code would look once it's actually being run. And so today we are going to discuss what the code actually looks like in the background, how to code the three tasks, what the pseudocode requires, what part mean what, and how to go about essentially completing the three tasks. So this is the pseudocode for this year's PRM for 2.3. So let's go ahead right into it. So here I have a bunch of variables and arrays and constants. Obviously, they're going to make little to no sense to you right now. But just for the sake of formalities, let's run through them. But don't worry if they don't make sense. They're not supposed to. They will only make sense once we actually go through them within the code. But just for a bit of an overview, let's go through them real quick. So we have baguette size and we have baguette size name, which are both arrays. The baguette size is an array of integer. The baguette size name is an array of string. Then we have bread type and bread type name. They're also both arrays. Then we have arrays of fillings, filling names. Then we have arrays of salad, salad name, salad choice list. Again, I'm going through them very briefly because um, their existence isn't really something that can be understood at this point, but it will make a lot more sense as we go along. So then we have variables. So all of these were arrays. Then we have variables that are size flag, bread flag, filling flag, salad flag, change order, cancel order, more order. Then we have order number. We have size choice, bread choice, filling choice, salad choice, and size. Then we have a constant, which is a salad. Sorry, it's a variable salad count, which is an integer which has an initialized value of 0. Then we have a variable add. Then we have the variables add salad, more size display, bread, filling, confirm order, change order choice, cancel order choice, more order choice, and count. So yeah, as you can see, there are a lot of variables and arrays this year, but the code has been as simplified as possible, and all of these are necessary, but they're actually really easy to understand why and to remember. So that will make a lot more sense when we actually encounter them in the code. So this is the part where we have to initialize all the values. So we say that all the values that we have declared, all the variables and the arrays, we actually need to initialize them. So we need to set the initial values in them. So we do that with a quick loop. So baguette size count is a variable that has indexes 1 and 2. So 1 to 2 means 1 and 2. And so we initialize each value of baguette size. So baguette size is basically an array with two values. So we run a loop for count is equals to 1 to 2. So this will iterate through the value 1 all the way up to value 2, which basically means 1 and 2. So it says baguette size count equals 0, where count is the iterative variable. What this means is that it is going to set the index of whatever count currently is in this array to 0. So baguette count, if for count equals 1, is going to be baguette size 1 equals 0, and then for count equals 2, baguette size 2 equals 0. So this initializes the entire the entire baguette size array. So next we have for count equals 1 to 3, we do the same thing for bed type. For count equals 1 to 6, we do that for fillings. And so essentially what we're doing is that we're looking at the highest index that is allowed for each of the variables, and then we're declaring them as initial values. So we're declaring them as 0. So next we have the baguette size name and the baguette size, the bread name type, the fillings name, etc. All of these arrays aren't counter arrays. So what we have to do is that we have to set the actual values that they hold. So the first index of baguette size name has the value 15 centimeters. So what baguette size name does is that it holds the name of the baguette size. So we have two baguette sizes as we discussed last time. We have 30 centimeter and we have 15 centimeter. So the first index is going to have 15 centimeter, the second index is going to have 30 centimeters, all because we need individual values that we're going to store and display as the code goes along. Next, we have the bread type name, which again borrows from this. So we have the bread type of white, we have the bread type of brown, we have the bread type of seeded bread. So each of these is stored in individual arrays, in individual elements of the array bread type name. Next, we have the fillings name, which does the same thing for the fillings. We have the salad name, which does the same thing for the salads. And if you notice, this will make sense now as to why these arrays were declared with the indexes that they have, with the allowed indexes. Is because bread type only has 3 types, fillings only have 6 fillings, as here, and salads have 5 salads as shown here. So the maximum number of indexes required are the number of values that they could possibly have. So next we have salad choice list 1, 2, and 3, which is initialized to nothing. So this is an empty string or a null string, and why this has been done will make sense in a bit. But essentially, what salad choice list does is that it updates the choices that the user has taken. So last time we discussed that salads aren't necessary to take, so the user is allowed to choose no salad, 1 salad, 2 salads, or 3 salads. And if they choose 1 salad, the first value, the first salad they choose will be stored in here. And if they choose 2 salads, the second salad will be chosen in here, and so forth and so on, all the way up to 3 maximum allowed salads. So then we initialize order number to 0. So we say order number equals 0 because there hasn't been an order yet. And now we say that more order equals true and change order equals true. These are Boolean variables, which will make sense when we actually go through the code. So I'm just going to initialize them as 0. Why we did that, I'll explain later. So then we enter a while loop. So a quick recap on the while loop. The while loop is a loop which checks a certain condition, and while that condition is true, it runs the loop. So here it may seem that the condition this is the condition, but whatever the condition is, the condition itself has to be true. So for example, right now it says more order equals true, which is true because more order has been initialized to true. So this comparison that more order should have the value true, this comparison is actually true, and so is going to run all of this, which is whatever is within the while loop. However, just for an understanding, if this says while more order equals false, and more order here had been initialized to false, so if this was false, then more order equals false would be a true comparison, because the value of more order, which is false, would be equals to whatever was written here, which would be false. So so essentially what that means is that they're asking, is false equals false, and obviously that's true, so it's going to run whatever the loop was. So we have a upper loop of while, or rather a outer loop of while more order equals true. And so if that value succeeds, then we'll say that we enter another loop, which is a nested loop of while change order equals true. And these two loops will make sense by like the end of task 1. So I'm going to just skip over them from now, and then I'll explain what each of these are doing when we get to that part. So don't worry about it just yet. Let's focus on the actual display first, and then we'll get back to the loop. So we say that the very first thing we have to do is output baguette sizes, and we have to output that 1 is for 15 centimeter and 2 is for 30. So this corresponds to what I showed last time in the emulator. In fact, let me pull it up again. So here we have baguette sizes 1, 15 centimeter to 30 centimeter from here to here. So this part corresponds to this part. So this is the information that the user is presented with. And then we have a size flag equals false. So we have a flag essentially that turns true when the user has entered a value for the size of the bread that we are accepting. So that's what size flag does. It is a flag to indicate that a correct value has been entered, and we may move forward with the rest of the code. So here we have size flag equals false, and we say that while size flag equals false, so while the user has not entered a correct value, we're going to run this loop. So all of this is going to be run until the user has entered a correct value. So we say output enter your choice 1 to 2, which is exactly what's happening here. So all of this happened up till here. Then between this line and this line, it used a flag. It initialized a flag, and then it checked that flag. And since that condition was true, so since size flag equals false, and since size flag has the value false, so essentially what this means is that while false equals false, which that condition is true, if that makes sense. So then it entered into this, and so it says that enter your choice. This is the prompt that we discussed last time. So the requirement was your program must include appropriate prompts, and so this is the prompt. And we say that input we're going to take an input, and whatever the input value is, we're going to store that value in the variable size choice. One thing you might have noticed is that all of these variables have names that allow us to understand what they're doing, and this is necessary as per this part, that all variables, constants, and other identifiers must have meaningful names. So this is a meaningful name. Size count is a meaning. Size choice, size flag. They're all meaningful names. What just happened? They're all meaningful names because they allow us to understand what they are doing. So we say that, so next we compare whatever value they have entered. So we say if size flag is less than 1, or sorry, not size flag, if size choice is less than 1 or size choice is greater than 2, then we say that please output sorry, we output please enter a valid choice of size between 1 and 2. So here we have we output the choices as 1 and 2. So these are the only two choices that they're allowed to enter. And so obviously if they entered anything but that, so if it was less than 1 or greater than 2, which means that it's not within the range that's allowed, that means that they entered a wrong value, and they must do it again. So otherwise, if this condition is false, which basically means that if the user has entered a correct value, then we say that then what we're doing is that we are updating the baguette size array. So we say baguette size choice is equals to baguette size of size choice plus 1. So there's a couple of things happening here. So what we're doing here is that we are entering the choice, which is a number. So number 1 corresponds to 15 centimeters and number 2 corresponds to 30 centimeters. And so what this is doing is that it's saying baguette size. Let's say, for example, the user entered 15 centimeters, so the user entered 1. So we say baguette size 1 equals baguette size 1 plus 1. What's happening here is that we are counting the number of 15 centimeter baguettes, which is the number 1. So here baguette size name 1 equals 15. So the value of the name value of the first index is 15 centimeters. So that's what's happening here. We're saying baguette size choice equals this plus 1. So essentially we're counting the number of each. So for example, if the user entered a 30 centimeter baguette, we'd say that a baguette size 2 equals baguette size 2 plus 1. So that would increment the number for the baguette size of 30 centimeters. So then we say the size flag equals true. This essentially means that yes, the user has entered a correct value. And so now when it exits the if and it exits the while, after it exits the while, it's going to try coming back into this. But the condition for which it enters this is size flag equals false. But here we have turned size flag to true. So this is going to be, this condition itself, this comparison is going to be false. So it's going to exit this loop altogether, and it's going to come here to the next part. So here we're doing the exact same thing with the bread choices. So last time we had a choice of we had the choice of size. This time we have the choice of the type of bread. So we're outputting the exact same thing again. We are outputting 1, 2, and 3, with each number is the corresponding bread choice, and then we put another flag as bread flag, and we do exactly the same thing again. However, this time the range is between 1 and 3. So if bread choice is less than 1 or bread choice is greater than 3, that means that the user has entered a wrong value, because we can enter either 1, 2, or 3. So anything that's outside this range, in other words less than 1, so this way, or greater than 3 this way, that's wrong. So we must tell them that they're wrong, and we must ask them to do it again. So else, if that's not it, then bread type equals bread choice equals bread type of bread choice equals bread type bread choice plus 1. So essentially it's the same thing. We have a different array which is recording the number and the number of choices made for each bread choice. And then again, we turn the Boolean flag true so that it does not go back into this loop. And then we go into the next part where we say that these are the baguette fillings. We output all the baguette fillings with their corresponding numbers. And then we say filling flag equals false. So again, we have a flag to represent whether or not a value has been entered. And then we say while filling flag equals false, we do all of this again. This time we have the range of filling choice less than 1 or filling choice greater than 6, because we have 6 values here. So any value less than 1 or any value greater than 6, that's a wrong value. And then we say that if the wrong value has not been entered, so if an error message is not prompted, then we update a new array called fillings, and we update that by incrementing it, because now we're storing the corresponding choice of filling by 1. So every time a user orders one of those, we increment that. So next we have salad count equals 0. So here we are going to be doing things a bit differently, because this time the user has a choice of whether or not they want to add a salad. And so if they do want to add a salad, then we also have to keep track of how many salads they want to add, or rather how many salads they've already added, because we cannot allow them to choose more than 3. So here we initialize a variable called salad count. Oh, and by the way, let me just show you all the rest what all the rest of the code does. We went through this briefly last time, but let's do it again. So let's say I want baguette size of 2. So then it asks me baguette type. I say 3, and then it asks me baguette filling. Let's say 2, and so then it would ask me all of this. So it would output the salad options from 1 to 5. Then it would say, would you like to add salads to your baguette, yes or no? So if I say yes, then it tells me all of this, which we will get to in a second. So then it says that input add salad. So whatever the yes no answer was, it's inputted into a variable called add salad, which I believe add salad up here we have declared all the way up here as a string. So it this time it's not having a numerical value, is having a string value. So because y and n are, well, they're actually characters, but we are allowed to use string as the data type here. So we say that if upper of add salad equals upper y. So essentially what's happening here is that when a user enters a string, they can enter either an uppercase or a lowercase string. So for example, if I had to enter a y, I could enter it like this, or I could enter it like this. So usually coding, it's case sensitive, so this would mean something completely different than this. So in order to make sure that it's easier for the user to access the actual code, and for us to understand what the user wants, we need a uniform source of understanding. So whether the user has entered a capital Y or a small y, we need to make sure that the code understands that yes, they do want to proceed. So what we've done is that we have taken the string that the user has entered, and we have converted it into an upper string using this method. So upper of whatever variable has that string, and then we're comparing that to a capital value of y by default. So if for example, if this had small y, then upper of small y is capital Y, and then we're comparing capital Y to capital Y, which of course is true. So then we say that salad flag equals false. So essentially what we're doing is that we're saying that if the user wants to add another salad, or like add salads to begin with, then we are repeating all of the process up here, except that this time we only declared this variable, or we only initialized this variable when we actually entered the if statement. So here we have more equals true, which is a Boolean variable, which we will come to in a minute. Of why this exists, we will come to in a minute. So we say that while salad flag equals false, or salad count is less than 3 and more equals true. So there's a couple of things happening here. So this loop, which allows the user to enter a salad, this only runs if either salad flag is false. So if the user has not entered a correct value, or if both of these conditions are true. So an and logical operator means that the both the conditions on each side have to be true. So salad count has to be less than 3. That means that the user has opted for has chosen less than 3 salads as of yet, and more equals true. So by now you might be able to understand that more is a variable which will show whether or not the user wants to add another salad. So if the user does indeed want to add another salad, so if it's true and he or she has not already added 3 salads, then this loop will run. So here we have we output the message that's shown here. So you may choose up to three. For now, it shows you may choose up to 3 salads. So what's actually happening here is that we're saying you may choose up to 3 minus salad count. So if salad count is 0, then 3 minus 0 is 3. That means that I may choose 3. So if I have, for example, chosen 2 salads, so salad count will be 2. So the remaining I have is 3 minus 2, which is 1. So I can choose one more salad because I can choose a total of 3. So here we have you may choose up to 3 minus salad count and uh, more salads. So this value is a separate calculation than the string. So it has to be in a way concatenated, even though you concatenate strings, but in an output statement in pseudocode, you can theoretically concatenate a value with a string. So we have you may choose up to this more salads. So enter your next choice, 1 to 5. So we enter these choices. Let's say I want the choice of 3. So then it asks me, or rather, then it actually makes sure that what I've entered is correct. So it says if salad choice is less than 1 or salad choice is greater than 5. So the least count we had is 1 and the greatest count we had is 5. So it says that if it's less than or greater than the extreme limits, then it says that please and enter a valid choice of salad, 1 to 5. And so it does all of that again. And this time, if the user has entered a correct value, then it does the same thing again to an array of salads. So each corresponding number contains the corresponding salad type. So salad 1 would contain the salad for lettuce. It would contain the number of salads chosen lettuce. Salad type 2 would contain the number of orders made for tomato, and so forth and so on. And so we say that salad flag is equals to true. So yes, um, there has been a correct value that is entered. And then we update a variable called salad count, which we encountered first up here. So we say salad count equals 0. So this time we are updating salad count because a valid choice has been made. Okay, and then we say that salad choice list, which is in another variable, which is another array that we have declared of salad count is equals to salad choice. So why we have done this again will make sense in the following task. So we're just going to breeze through this right now because we will encounter this array again in task 2 and 3. So just ignore that this exists for now, but this is necessary for the following tasks. Okay. So then it says if salad count is less than 3. So basically that means if the user has not already chosen 3 salads, then we output would you like to add another salad. So if the user says yes, then that input is stored in more. I mean, if he or she says no, that's also stored in more. But the response of the user is stored in more. So if upper of more is equals to y, so if the user entered yes, and so we're doing the same upper conversion method here again. So if it's equal to yes, if it's equal to y, then more is equals to true. Else more is equals to false. So we had a boolean variable here that's called more. So we say that if it's yes, then it's true. If it's no, then it's false. And then we end all the ifs, and then we end the while. So this while goes all the way up here into this while. So we said that while salad flag equals false or salad count is less than 3 and more is equals to true. So this is the part that is being affected. So once more has been updated, this may be true or this may be false. Okay, so that is the salad that is the salad part of task 1. So next we say that size display equals baguette size name size choice. So all right, okay, so this is the part where things can get a little bit tricky. So what's happening here is that the size that we have chosen, whether 15 centimeter or 30 centimeter, is stored in size choice. And so whatever value of size choice is, we are going to use the corresponding baguette size name. So let's say I ordered 1 for size choice, I ordered 1. So baguette size name 1 is 15 centimeters. So the reason we have all of these is so that we can actually display the choice that the user has made back to the user. So if we come back all the way down, back down here, then whatever whatever the choice that the user has made, that I will store in size display. And similarly, whatever the bread choice was, I will go into the corresponding array element for bread type name, and I'll store that as bread. And then I'll do the same thing again for fillings name, and I'll store that in filling. And then I'll output a bunch of information which relates to the actual the thing that the user has chosen. So I'll say I'll output your ordered baguettes, your ordered baguette, which basically means this. So let me show you. Add another salad. No, I would not. So here, this is the final menu. So your ordered baguette size equals 30, bread equals seeded, fillings equals chicken, and salad equals sweet corn, which is all the options I have chosen. Whoa, which is all the options I have chosen here. So the way it keeps track of these options is that it says that is through looking at the choices we have made and then the corresponding names. And so we say that size is size display, bread is bread, filling is filling, and then for salads, what we're doing is a special technique where we are saying that we are looping through the salad count. So we're saying that for salad count equals 1 to 3, if salad choice list of salad count is not equals to nothing. So okay, so we need to understand a bit here. So here is the actual use of the salad choice list array that we had chosen. So salad choice list is encountered again in this task, in task 1. And so we say that salad choice list of salad count. So basically, let's say, let's come back here. Where is it? Yeah. So if salad choice list of salad count is not equals to null, so salad choice list up here we initialize as null string. So the first salad was nothing, the second salad was nothing, and the third salad was nothing. So essentially what it's doing down here is that it is seeing whether the first element, so for salad count equals 1, is going to go through salad choice list equals salad choice list of 1. So if we have ordered only one salad, then the value of the first salad is going to be stored in the first index of salad choice list. So salad choice list 1 will contain the value that we have. But if it's not equals to null, so if there is a value in it, then we will output the salad name for the value stored at this variable. So here, this contains a value. So for example, if I chose a salad count of 1, so if I chose the first option of the salad, that salad will be stored in this array, in the particular element, in the first element of this array. If it was the first salad I chose, it will be in the first element. So if the value of the salad of the first element is stored in this, then this and this is the same thing. So this element is the same as this, and so this represents a value. And so if the salad name of that value, so the salad name of that value will be the actual name of the salad. I hope that makes sense. So what that means basically is, let's say we chose 3. So 3 was sweet corn. So sweet corn is in salad named 3 because it's the third salad. But the fact that we chose sweet corn was saved in this variable. It was saved in the first element because it's the first thing we ordered, in the first element of salad choice list. So that is then retrieved in order for us to display it like this. So we are outputting the salad name of whatever is stored in here, which is the choice that we made. So I hope that makes sense. So next, once we have looped through this 3 times, so for example, if we've only chosen 1 like we have here, so the next time it increments salad count, it says salad count equals 2. And for salad choice list of 2, there's going to be a null string because all 3 were initialized to null, as we saw up here. All 3 were initialized to null. And so if I ordered only one salad, then only the first choice has been updated. So once we go through that, it's going to go through the rest of these, but this condition is going to be false because it's not equals to nothing, because it is equals to nothing. So then it's not going to output this, and essentially it's going to go through the rest untouched. And then we say that then we ask the user to confirm their order. We say that confirm order yes or no, and then the input is taken in confirm order. And if again, to make sure that whatever they entered makes sense to us as the perspective of the actual program, then we convert both of them to upper. So we say the input, and we compare that to the upper value of n. So if it's false, so if the user has not confirmed the order, if they wish to cancel the order or change it, that means that confirm order equals false, change order equals false, and cancel order equals false. These two will make sense in just a minute, but this essentially means that the user has not confirmed the order. So then we come into this while loop, while change order equals false and cancel order equals false. So both of these have to be false for this loop to work. We output, would you like to change your order or cancel it? So if the user likes to the change it, then the user enters change. If they want to cancel it, the user enters cancel. And so we say, then we input whatever they want in change order choice. So whether they want to change it or they want to cancel it, that string is stored into change order choice. So we say that if upper of change order choice, um, so if whatever was entered, either this or this, whatever capital values, so for example, let's say I say no, then would you like to change your order or cancel it? Let's say I say change it. So this value, oh, so now it refreshes the screen, of course, but what happened before that is that it ran through this. So it said that the change value, if you notice, I entered in small letters, but it converted all of those small letters into upper letters, and then it compared that to upper change. And if that was true, then change order equals true because I want to change it. Otherwise, if else if, which basically means otherwise, if the value stored was cancel, if the upper of the value I entered was cancel, then I say cancel order equals true. Else, if none of these two were input, if none of these two are satisfied, that means that the only two options that were valid have not been entered. That means the user entered a wrong value. So I say that please output a valid choice. Then I say, here the initial if was if upper confirm order equals no. So the user has not confirmed the order. However, if the upper confirm order equals yes, that means the user does want to confirm the order. Then we say that change order equals false, cancel order equals false, because none of these two are true, and order number is finally incremented, because as we saw here, we have to keep track of the order number. And so as the user keeps ordering, we just increment the value, because the user just keeps ordering more. And then we say that then we output your order number is, and we output the order number. And then we terminate the if condition, and then we also exit the while loop. So then it says that and this while loop is governed by um, this wait, where is it? This while loop goes back to here. So it says that while change order equals false and cancel order equals false. So while this is true, it's going to keep doing this. If both of these are turned if either of these are turned to true, then it will exit the loop. And so that's what it does here. So it says, if the user does not wish to cancel it, then we say, would you like to order another baguette? So then whatever the response of the user is, we store that in more order value. So if upper of more order value equals yes, so again the same principle again. So then we say that more order equals true. Otherwise, more order equals false. And if more order equals false, then we call the task 2 3. Task 2 3 basically means that it is a hybrid of task 2 and task 3. So the procedure for task 2 3 will contain the code for both tasks 2 and 3. So while the user does want to order another baguette, this is going to keep running. And if they choose that, no, I don't want to order another baguette, then we call the second and third tasks. So up till here, we have finished the code for task 1. It might look, it is long and it might look complicated, but it's not that complicated, because once you get the hang of it, all that we're really doing is that we're outputting and we're storing and we're storing whatever the user has input. So next we go into the procedure for task 2 and 3, which is what we would call here. So this task is a hybrid of both tasks 2 and 3. So I'll let you know which parts are required for task 2 and which parts are required for task 3. So here we declare a whole new set of variables. You might be fed up of variables at this point, and I don't blame you, but unfortunately it is necessary for this PRM. So we say that total size 15, we declare total size 15 as an integer, we declare total size 30 as an integer, then we declare total bread white, total bread brown, total bread seeded, total filling beef, and so on and so forth. I think you get the idea. Basically, what we're doing is that we are declaring the total values for each of the types that were ordered. So each of the filling type that was ordered, each of the brown bread that was ordered, each of the size that was ordered, and so forth and so on, through all of the data, all of the options that we have given the user so far. And then we say that the total baguette sold is also an integer, so we declare that. And right off the bat, we say that the total baguettes sold is equals to the order number. So whatever the order number is, so whatever the highest order number was. So let's say that 5 customers order baguettes in a day. So the last order number, the highest order number, is going to be 5. And so clearly only 5 baguettes were sold, and so we'll appoint that value of 5 directly to the total baguettes sold. Then we say that total size 15 equals to baguette size 1. So baguette size 1 stores the number of baguettes ordered for the type 1. So type 1, if we go all the way back here, type 1 was 15 centimeters. And so that's what's stored in baguette size 1. If we come back here, and then we say total size 30 equals baguette size 2, and we do the same for all of the fillings and the brown bread, and for all the bread and the fillings, we enter the corresponding values of whatever the total number of that choice was that day. Notice that we haven't done that for salads because that's not required. The only thing we need to do is to record the totals for the size, the types of bread, and the fillings sold that day. So salads are not included. So thank God for that. But because that would be a whole nother process, because we need conditions, how many salads have been chosen, and so forth and so on. So it's a good thing that that's not required. But however, here we have a whole new set of variables where most filling is an integer, least filling is an integer, most popular percentage and least popular percentage are reals, and the most popular name and the least popular name is a string which has a value of 0. So then we initialize the values for most filling and least filling as the value shown. So these values will make a lot more sense as we go along. But for now, let's just understand that the most filling is a negative value and the least filling is a positive value. Why, that will make sense in a bit, but let's just look at this here. So for count equals 1 to 6, so we are now iterating through a loop again. We say that if fillings count is greater than the most fillings done. So here is why we initialize these values. So let's say that a user has a total filling of let's say that the most fillings made were 3, right? So the fact that the fillings of that count is greater than the most fillings so far. So when we run through the loop, we see what the most value of the filling is. And so if that particular value exceeds the previous highest, then we say that we need to record that value as the new highest. However, to begin with, if this was a positive number, then there is a chance that the highest value is less than the initialized value. But if that's the case, then our code would break down and not work. So the upper limit needs to be a negative number, so that whatever the positive integer that was entered is, if that's a positive value, that can be recognized as being more than this negative value, and that can be updated. I hope that made sense. If not, I'll go back through that and we'll see that once again. So if fillings of count, so if the number of fillings of that particular filling is exceeding the most fillings, which is the current highest number of fillings. Then we say that most fillings equals to the filling that we currently have. So the number of so for example, let's say that chicken was ordered 6 times, and that is the maximum that we have so far. So whatever this was, whatever the previous maximum was, the chicken's filling will exceed that, because that is the maximum number. So we set the maximum number to this new value that we have seen to be greater than the previous maximum. Again, I hope that makes sense. There's a lot to digest here, but I'll go back through this once again just to make sure that everyone is on the same page. So here we have most popular name equals fillings name. So once we have identified what the most number of fillings was, we also have to show, as per the PRM says here, so display the most popular and the least popular fillings. So here we have the most popular name equals fillings name. So let's say that for the first count, if this count number succeeded in being the most ordered for, so that means that this count contains the filling name, or rather the name of the filling. So let's say, for example, chicken. I keep coming back to chicken, but it can be anything. It can be cheese, egg, anything. Any of the fillings that was contained at that particular value of count, that name, which is stored in fillings name, that name is the name of the most popular filling that was ordered. So then we record that as the most popular name. Else, if it's not the maximum, then we see if the fillings count. So if the number of fillings ordered for that particular filling, God, I hope this is making sense. I'll go back through this again. But if the number of that particular filling ordered is less than the least filling, so if it's less than the least value for the fillings, then we do the same thing again, but this time the variables are least filling, which is being updated by the current value, and the least popular name, which is being updated by the current value's name. So this is why we initialize the least filling to a ridiculously high number. I mean, no one's gonna order 10,000 baguettes in a day, but this is why it's this high of a number, because any value that is added will be less than this value, and so the cycle will begin properly. Okay, so if none of these conditions were met, that means that that means that the filling that was ordered is just a mediocre level. It's neither the maximum nor the minimum, so we don't really care about it. So then we move on to this part where we say that the most popular percentage, so the percentage of the most popular filling. So in fact, let's have a look back at the PRM here. So it says, using your results from task 2, display the most popular and least popular fillings as a percentage of the total number of baguettes sold that day. So as a percentage of the total number of baguettes means that whatever the number of fillings was, we divide that by the total number of baguettes sold, and we multiply that by 100, because that's how percentages work. So we say that the most popular percentage was the value of the most filling, which again is a number. So which is stored in here, which is the value, which is the number for the value of most popular filling. So for example, if beef was ordered 3 times and 3 times was the maximum, then most filling will contain 3. So it will say that most filling, which is 3, divided by the total number of orders that day, multiplied by 100, will give you the percentage of the fillings ordered as a percentage of the total number of baguettes, which again is stored in order number. And then we do the same thing for the least popular percentage. So we say that the least filling divided by order number equals 100. So now we have the most popular percentage and we have the least popular percentage. And the final thing we have to do is display the most popular and least popular fillings as a percentage of the total numbers of baguettes sold that day. So that part is taken care of by dividing it by order number. And so next we say that the most popular baguette filling was, and then we compound it with the name of the most popular filling, so which we set here, and we say that had an order of, and then we say most popular percentage, and we say percent. So and then we output the least popular baguette filling. We do the same thing, but this time the variable we are outputting is the least popular name, and we say with an order of whatever the least popular percentage was, percent. And there we have it. We are done with task 2 and 3. So this task might have been like a bit more to understand, but I hope it made sense. So essentially, what we're doing here is essentially this task contains three parts, or rather two parts. One is the declarations. So one is the identification of which is the least value, which is the greatest value, and then we just have to apply the calculations to those values. So what we're doing here is that we're comparing if the current number of orders exceeds the most number of orders for that particular filling, then we record that okay, this or number of order is the new maximum. And similarly here, we're saying that if it's less than the previous least filling, then this is the new minimum. And then we just get, excuse me, and then we just perform the calculations necessary on those values, and then we output them. So that is the requirements of task 2 and 3. So task 2 was extend task 1 to record totals for the size, type of bread, and fillings. So that's what we did right here. So this is task 2, where we are recording the totals for each type of bread, filling, and size. So this from here, excuse me, from here to here, if it allows me to go down enough. So let's say here to here. This is task 2. So this is all the task you will, this is all the code you will require for fulfilling task 2. And then everything down here is the code for task 3. So all of this. We're here. Task 3 says that using your results from task 2, display the most popular and least popular percentage, the least popular filling as a percentage of the total number of baguettes. So that is what we've done here. We have identified the most popular and the least popular. We have saved their names, and then we have said that, and then we have calculated their number as a percentage, and then we have output what they are. So there you have it. That is the pseudocode for both task 2 and 3 and task 1. So if you go through the emulator right again, so if I refresh this, let me just go through it again. A moment. So if we say that I want to order a 2, 3, I'm just going through this quickly. So I want to order egg. I do not want any salads. No, thank you. I want to, I want to confirm my order. So task 2, um, so task 2 is run if the customer confirms their order. So confirm order, yes. Would I like to so now the order number is 1. So would I like to order another baguette? Let's say yes, I would. So I want to show you what happens to the order number. And so now if I say I want to, so basically every time I order a new baguette, it's going to run through all of this again, and it's going to increment the order number. So next time it's going to be 2, next time it's going to be 3, 4, 5, and so on. So now if I say no, then it goes through all of this. So when more order equals false, so I don't want to order another baguette, then then it's going to call task 2 and 3, where all of this is going to happen. So all of this is happening in the background. The only thing the user sees are the few tiny lines of outcode. So I say, so because I only ordered the egg, so the only filling I ordered in this entire program was the number 4, and then I didn't order another one. Then it says that the most popular baguette filling with egg was egg with an order of 100%, because obviously that was the only one I ordered, and the least popular baguette was chicken. So obviously there's going to be all of the values which have a value of 0, and so it's just going to choose anyone. So with a large enough program with large enough orders, this value will be fixed. However, it would have been just too long of a code and unnecessary as per exam requirements to account for the fact that all of them are going to be 0. So this code will work. This line will work without a problem when there are actual like hundreds of orders as there are in a real life scenario. But from an exam perspective, this is more than enough to account for a valid code. So there you have it. That is how the code is going to work and how it's going to look once it's done working. And that is the pseudocode for tasks 1, 2, and 3. So that covers all of the variant 2, 3 for this year. I hope it made sense. If there are any questions or anything you would like me to repeat or anything to elaborate on, please feel free to leave that in the comments down below, and I will be happy to respond. And if you enjoyed it, then I like to always appreciate it. And if there's any questions, like I said, feel free to let me know. And yeah, that is about it. I hope you understood, and have a good day.